Welcome back to the deep dive. If you're anything like, well, most cloud architects or engineering leaders out there, you've probably felt that familiar gut punch at the end of the month. You know, the cloud bill.
Oh, yeah.
Specifically, the sticker shock from something as fundamental, you'd think, as a database. It's incredibly easy these days to deploy a really powerful, scalable database in the cloud.
Super easy. Click, click, done.
But the real trick, the real challenge, is managing its cost effectively.
And that's exactly where so many organizations get tripped up. It's that hidden complexity of cloud economics that, we're really going to try and unravel today.
Right.
So our deep dive is focused on a critical topic: mastering Azure SQL Database costs, a strategic guide to financial governance. And this isn't just about, understanding your bill after the fact.
No.
It's really about providing a comprehensive strategic playbook, moving beyond just reacting to those charges.
Okay, so our mission today is pretty clear. We're going to dissect the key strategies, those nuanced architectural patterns, and maybe those often overlooked financial levers that give you, total cost control over your Azure SQL Database instances. We want to help ensure that the solutions you build are not just powerful and reliable, but crucially, financially sustainable, for the long run.
Exactly. And this channel, it's dedicated to databases, data engineering, and architecture, and we bring you new insights every week. Our goal, really, is to offer you that shortcut to being well-informed, helping you catch up and, stay ahead in a world where technology is just changing faster than ever.
It really is.
So if you find value in what we share today, please hit that like button, subscribe, follow us. We'll have more deep dives into these kinds of critical cloud topics.
And specifically for this deep dive, we're really zeroing in on the databases and data engineering aspects, the impacts, the trends, the opportunities that the source material presents. So let's unpack this fundamental tension. It sits right at the core of cloud architecture.
Yeah.
You know that feeling, right? How do you balance these two forces that seem to be pulling in opposite directions? On one side, you've got reliability, that absolute need for uptime, for your apps to be there when users need them.
Can't compromise on that often.
Exactly. But then on the other side, you have cost optimization, that constant pressure to deliver value efficiently without, breaking the bank. These two pillars, they're recognized right in the Azure well-architected framework, but yeah, they're often in direct opposition. It creates a fascinating challenge for any cloud pro.
And that is precisely the challenge, because what's often surprising to people, I think, is how achieving higher levels of reliability inherently demands more redundancy. It sounds simple, maybe obvious, but that redundancy comes with a very direct and often escalating cost implication. More infrastructure, more services, more sophisticated configurations.
More money.
Ultimately, more investment. It's a direct correlation. You can't really avoid it.
So let's talk specifics. The cost of uptime. Azure SQL Database, just right out of the box, it gives you a baseline availability SLA of 99.99%. 4 nines.
Which sounds fantastic.
It does. And for many applications, that's perfectly fine. It works out to, roughly 52 minutes of acceptable downtime per year?
Something like that, yeah.
But then for those truly mission-critical workloads, the ones that absolutely cannot afford even a tiny glitch, you might start looking at something called zone redundancy.
Okay, and this is where the cost curve really starts to bend, sometimes unexpectedly steeply. Zone redundancy works by replicating your database across physically separate availability zones within an Azure region.
Right, like mini data centers.
Exactly. Think of them as independent buildings, basically, each with its own isolated power, cooling, networking infrastructure. The whole idea is, if one zone goes down, a rare event, but it happens, your database can seamlessly fail over to another one. It mitigates those single data center failures, ensures continued operation. And doing this, it elevates your availability SLA to 99.995%.
Yeah.
5 nines, essentially.
Now, that jump from 99.99% to 99.995%, it might seem infinitesimally tiny on paper, just half a 9.
Yeah, easy to dismiss.
Very easy. But the source material really highlights this. The engineering effort and, critically, the Azure spend required to get that extra 0.005% of uptime. It's not just significant, it's often exponential.
It's not a linear climb at all.
No, it's a very steep one. Think of it like, trying to perfectly line a million dominoes. Those last few tiny adjustments take way more effort and precision than setting up the first 1,000.
Good analogy. Or polishing a lens, maybe. Getting that final microscopic reduction in imperfection becomes incredibly expensive, resource intensive.
Right, and that's the real cost of chasing that final fraction of a percent. It can easily become Well, a black hole for your budget if it's not genuinely required by the business.
Which brings us to a really fundamental question, and honestly, the first strategic imperative for any cloud database professional. What is the required reliability for your specific workload?
Okay.
The first, most crucial step in truly effective cost optimization isn't about tweaking settings after you've deployed everything. It's about having a transparent, data-driven conversation with your business stakeholders before you start.
Right up front.
You need to collectively define that required reliability in concrete terms, measurable terms. Because, as we've just discussed, this foundational decision dictates the entire architectural approach you take, the services you consume, and, consequently, its associated costs.
Makes sense.
Without that clarity, you risk either overspending on reliability you don't actually need, or, maybe worse, under-provisioning for critical systems and facing outages.
That's a huge point. So, okay, what's the concrete action here? What should the cloud database professional listening do first?
Action proposed. The absolute first step is to sit down with your business teams. Explicitly define that required reliability for each database. Ask the hard questions. Is 99.99% genuinely enough for this specific workload? Can the business tolerate roughly 52 minutes of downtime annually? Or do you truly need that 99.995%, pushing acceptable downtime down to just a few minutes per year? Understand the real business impact of each scenario. This foundational decision is the cornerstone of your whole cost strategy. It'll save you from massive overspending later, because without a clear requirement, the default tends to be as much reliability as possible.
Which usually means as much cost as possible.
Exactly.
Okay, so now, once you have that clarity on reliability, we can move on to the core architectural decisions. Before you even think about provisioning a single database, there are these two foundational architectural choices that will profoundly define its performance, its reliability, and, most importantly for this deep dive, its cost structure.
That's right. These aren't minor tweaks. These are the big, macro-level decisions that set the whole stage for your financial governance later on.
So the first choice you face is between the vCore and DTU purchasing models. Azure SQL Database offers these two distinct ways to pay for resources, and each has its own philosophy, its own implications, and, different cost paths.
Understanding the nuances here is really crucial. Let's start with the vCore model.
Okay.
This is generally seen as the sort of professional standard for mission-critical workloads, and for good reason. It gives you very granular control and transparency over your resources.
What does that mean in practice, though? Granular control?
It means you can independently choose and scale your compute resources, so your vCores and memory, separately from your storage resources, whether that's standard HDD or premium SSD or whatever.
Okay.
The costs are broken down, component by component. You see exactly what you're paying for. You're picking specific hardware generations, specific compute-to-storage ratios. It really embodies that cloud elasticity idea.
The beauty of the vCore model, then, is this precision tuning.
Exactly. It's ideal for performance-sensitive workloads, where you need to fine-tune resources to get the optimal price-to-performance ratio. You're not, hopefully, overpaying for something you don't need.
Or under-provisioning.
Right. Or you can scale up precisely when demand spikes. But what's also critical to understand, and this is a huge cost lever, is that the vCore model is a prerequisite for leveraging some of the most significant cost-saving instruments Azure offers.
Like what?
Like Azure Hybrid Benefit and reserved instances. You simply cannot use those powerful levers, which can slash costs by, 50–70% sometimes with the DTU model.
Wow, okay, that's huge.
It is. That alone often makes vCore the more financially savvy choice in the long run for any established, serious workload.
Okay, so then we have the DTU model. This one sounds like it's designed for simplicity, almost a set it and forget it kind of approach.
Yeah, that's the idea. It bundles compute, storage, and I/O resources into a single abstracted unit. They call it a database transaction unit, or DTU. And you pay a fixed price for a certain number of DTUs.
Straightforward.
Very straightforward. Easy to understand. It's well suited for new or maybe simpler applications with predictable usage. Low to moderate usage patterns where ease of management is really the top priority over granular control.
Like maybe a small internal app.
Yeah.
Or a proof of concept.
Exactly. Or maybe a dev environment where the performance profile is well understood and pretty static.
But there's always a but.
There's always a trade-off, yeah.
Good.
That simplicity comes at the cost of control. With the DTU model, you can't choose the underlying hardware generation, nor can you scale compute and storage independently.
Which can lead to?
Often leads to inefficient resource utilization. For instance, say your workload is constrained by just one resource. Let's say Your I/O performance is constantly hitting the ceiling, but your CPU and memory are barely ticking over. You might find yourself forced to over-provision on DTUs, maybe jump to the next tier up, just to get enough I/O, which means you're paying for far more compute or memory than you actually need, simply because it's all bundled together.
It's like buying a bigger house just because you need more closet space, like you said.
Exactly. Even though the rest of the rooms are empty, that inefficiency can silently inflate your monthly bill over time, especially if you're not watching closely.
Okay, so understanding that fundamental difference is vital. What's the action item here for our cloud database professionals? What's the best practice?
Action proposed. For granular control, transparency, and critically, access to those significant cost savings like Azure Hybrid Benefit and reserved instances, you should almost always opt for the vCore model, particularly for production or any performance-sensitive workloads.
Almost always.
Yeah. Only consider DTU for truly simple, predictable, and non-critical scenarios where the absolute ease of management and a fixed abstract price are genuinely the highest priorities. The long-term cost benefits and optimization opportunities of vCore usually outweigh that initial, maybe slightly steeper, learning curve for most serious evolving workloads. Make this choice deliberately. Don't just default to one or the other.
Okay, makes sense. So once you've made that foundational decision, maybe you've chosen the vCore model, your next critical choice is the service tier.
Right, and this choice represents a really direct trade-off between cost, performance, and reliability. It directly impacts the level of availability and the I/O throughput your database will offer.
So it's about matching the business need to the right tech level, not just picking the shiniest, most robust option.
Precisely. Let's break down the main tiers within vCore, starting with general purpose.
Okay, the default one often.
Off to the default, yeah. It's budget-oriented, designed for most common business workloads. Its architecture separates compute from storage. Compute is managed by Azure. Storage relies on Azure Premium Storage typically. Offers a good balance of performance and cost efficiency.
But here's a crucial detail, right? For cost.
Yes. Zone redundancy is not enabled by default in this tier.
Ah.
You have to explicitly configure it, which means paying extra, an additional investment if you want that higher availability against zonal failures. Without that explicit configuration, you're looking at the standard 99.99% SLA operating within a single availability zone.
So good for everyday business apps, web apps, departmental databases maybe, where cost efficiency is key.
Exactly. Where extreme resilience isn't the absolute top requirement.
Then there's the business critical tier. Sounds serious.
It is. As the name suggests, this tier is engineered for applications that demand extremely low latency I/O, think high-volume transactional systems, and need really rapid recovery from failures.
How does it achieve that?
It uses multiple isolated replicas internally for high availability, and it also provides built-in read-scale replicas, which is nice for offloading read workloads. But here's the key thing for cost and reliability.
What's that?
Zone redundancy is included in the base price.
No, okay, so it's built in.
Built in, which means you automatically get the higher 99.9995% SLA right out of the box with synchronized replicas spread across zones. No extra configuration needed for that level of HA.
So this is the go-to for mission-critical apps, core banking, critical e-commerce, real-time analytics dashboards.
Pretty much. If you need the highest in-region availability and performance from day one, business critical is often the answer. But naturally, the cost premium reflects that built-in resilience. You pay for it.
And finally, we have the Hyperscale tier. This sounds different.
It is very different. This is Azure SQL Database's truly cloud-native architecture, designed for immense scalability and performance. It fundamentally decouples the database engine, the compute layer, where queries run from the storage layer where the data actually lives.
How does that help?
Unlike traditional designs, Hyperscale uses things like a shared page server architecture and a distributed log service. This separation allows each component, compute, storage, to scale independently and massively. Your database can grow into terabytes, even petabytes.
Yeah.
It's ideal for workloads with extremely spiky or unpredictable demands.
Yeah, okay, big scale. What about zone redundancy for Hyperscale?
It's supported, but similar to general purpose, it must be configured separately. It's not included by default like in business critical.
So architects can choose.
Exactly.
Yeah.
It gives architects the flexibility to opt into the 99.995% SLA only when their specific needs dictate it. Offers a balance between that extreme scale and optional zonal resilience. Think large-scale suffice apps, massive IoT data ingestion, very large data warehousing scenarios where data growth is, hard to predict.
That's a fantastic breakdown of the trade-offs. So for our cloud database professional listening, what's the ultimate action item from choosing a service tier?
Action proposed. The importance of verifying whether your database truly requires general purpose, business critical, or hyperscale cannot be overstated. Base it on specific reliability, performance, and scalability needs. Don't just pick business critical because it sounds robust.
Understand the cost premium.
Understand the significant cost premium for that included zone redundancy and the underlying architecture. You might be paying for way more reliability or performance than your business actually demands.
Or the opposite.
Or conversely, you might underspend and end up impacting critical operations. The advice is, conduct thorough load testing. Do performance baselining to really inform this decision with data. Don't guess.
Okay, solid advice. So far, we've focused a lot on high availability, HA, which protects against failures within a single region. But what happens if an entire Azure region has a major problem, a catastrophic widespread failure?
Right, that's where disaster recovery, or DR, comes into play. It's a critical component of any comprehensive business continuity plan. And it has its own distinct set of cost implications, often quite significant ones.
Yeah, DR isn't usually cheap.
Not usually, no. And when discussing disaster recovery, there are two key metrics that are absolutely critical to define with your business stakeholders, just like we talked about with reliability.
Let me guess. RTO and RKO?
You got it. Recovery time objective, RTO, and recovery point objective, RPO. Without clear, agreed-upon definitions for these, any DR solution you implement might be either wildly over-engineered and costly or just woefully inadequate when disaster strikes.
Let's break those down quickly because they do get confused sometimes. RTO, recovery time objective. That's the maximum acceptable time before your application is fully recovered and back online after something bad happens. It's about how quickly you need to be operational again.
Right. So an RTO of 1 hour means the business says, okay, we can tolerate being down for no more than 60 minutes.
And then RPO, recovery point objective. That's the maximum acceptable amount of data loss that can be tolerated from an unplanned event. It tells you how much data you can afford to lose, measured in time back from the disaster.
Exactly. An RPO of 5 minutes means you absolutely cannot lose more than the last 5 minutes worth of transactions or data changes. And naturally, the lower your RTO and RPO targets, the faster you need to recover, and the less data you can lose, the higher the complexity and inevitably the cost of the DR solution.
Okay, so Azure SQL Database offers several DR options, right? Each with different RTO-Corpo capabilities and costs.
That's right. Let's start with active Geo-Replication. This lets you create continuously synchronized, readable secondary databases in any Azure region you choose. The replication is asynchronous, but it provides near real-time data copies over there.
Okay, readable secondaries, that's useful. What about RTOR-PO?
With active Geo-Replication, you generally get a really fast RTO, typically under 60 seconds, which is fantastic for rapid recovery.
Yeah.
The RPO is usually very low too, often seconds.
Sounds great. What's the catch?
The catch is that you have to manually manage the failover process yourself. An operator or a script has to initiate the failover command.
Okay. Human intervention.
Potentially. And more importantly, your application connection strings usually need to be updated after a failover to point to the new primary database in the other region.
Right, because the server name changes.
Exactly. That adds a layer of operational complexity, potential for manual steps in your recovery plan, which can introduce delays or human error. Plus, you're essentially paying for 2 active databases compute-wise, which impacts cost.
Okay, so building on that, there's failover groups.
Yes, failover groups. Yeah. This is generally the recommended option for most serious DR scenarios, especially for production workloads. It basically builds on top of Geo-Replication, but lets you manage the replication and failover of a group of databases together as a single unit.
So if my app uses like 3 databases, they all fail over together.
Correct. They fail over consistently. But the key advantage here, and this is a massive simplification for recovery, is that failover groups provide a stable listener endpoint.
What does that mean?
It means your application connection strings do not need to change after a failover. They just keep pointing to the listener endpoint address.
And the listener redirects.
The listener automatically redirects traffic to whichever database is currently the primary, whether it's in the original region or the DR region. This makes the recovery process much smoother, faster, and way less error-prone from an application perspective. It really streamlines the whole RTO process.
Okay, that sounds significantly better operationally, probably costs more.
There's still the cost of the secondary resources, yes, but the operational simplicity often justifies it for critical apps.
And then on The more basic, maybe cheaper end?
Right, on the more basic, cost-effective end of the spectrum, we have Geo-Restore. This is a simpler DR option where you restore a database from geo-replicated backups. Azure automatically takes backups and stores them, usually in a paired region, for you.
So you just restore from backup if needed.
Pretty much. It's incredibly easy to use. But the trade-off is a much higher. RKO could be minutes, could be several hours, depending on the database size and activity. And a higher RPO too, potentially up to an hour of data loss, because you're restoring from the last available geo-replicated backup, not an active replica.
Okay, so restoring from backup takes time, and the backup might be an hour old.
Exactly. So given these characteristics, Geo-Restore is really only suitable for non-critical applications. Things where significant downtime and potential data loss are acceptable to the business.
Like internal reporting databases, historical archives, dev test?
Perfect examples. It's the most budget-friendly DR option because you're not paying for a continuously running, replicated secondary database. But the limitations in recovery time and data freshness are very clear. The cost savings are there, but so are the compromises.
This leads us to another vital consideration, another action item for the cloud database professional. Strategic DR planning. What should they really keep front of mind?
Action proposed. Selecting the appropriate DR option is absolutely crucial, and it must align precisely with your business's defined RTO and RPO needs. Don't overspend on a super sophisticated DR solution with sub-minute RTO if your business can genuinely tolerate hours of downtime and maybe losing an hour of data.
Don't underspend either.
Exactly. Conversely, do not underspend if your business absolutely depends on rapid recovery and minimal data loss. The operational and financial impact of a prolonged outage in that case will far, far outweigh any perceived savings from picking a cheaper DR option.
So document the plan, test it.
Thoroughly document your DR plan, test it regularly, actually simulate a failover, and make sure everyone understands the associated cost implications of the chosen strategy.
Okay, now that we've covered those foundational architectural decisions, purchasing models, service tiers, HA, DR, let's move beyond that foundation. Because even once those choices are made, you can still apply several strategic levers to dramatically cut your costs.
Right. This is where smart financial planning really meets technical execution. These levers can often turn significant expenses into much more manageable ones.
Let's start with financial instruments. These sound like powerful tools.
They really are. When used correctly, they can significantly change your total cost of ownership for Azure SQL Database. Sometimes by, more than 50%.
Okay, the first one you mentioned earlier, Azure Hybrid Benefit, AHB. This sounds huge for companies with existing licenses.
It is. It's a powerful licensing benefit. It basically lets you use your existing on-premises Windows Server and SQL Server licenses, provided they have active software assurance in Azure.
So you bring your own license?
Essentially, yes. By bringing those licenses to Azure, you pay a significantly reduced rate, they call it the base compute rate, on your Azure SQL services. It often saves up to 55% just on the SQL Server licensing portion of the cost. It lets you reuse that investment you already made.
That's a prime example of getting more value from what you already own.
Totally. So for the cloud database professional, the action here is clear. Action proposed. Actively audit your existing on-premises SQL Server licenses. If you have active software assurance, make sure you're utilizing Azure Hybrid Benefit to transfer those licenses to Azure whenever possible, especially if you're using the vCore model, which supports it.
Got it. Talk to the licensing team.
Absolutely. Make sure your licensing team and your cloud architects are totally in sync on this. It's one of the most immediate and substantial cost savings available, often just waiting to be claimed.
Okay, next up, reserved instances. Or reservations.
Right. If you have stable, long-running workloads, and let's be honest, most production databases fall into this category, Azure reservations offer huge discounts, sometimes up to 72% compared to standard pay-as-you-go pricing.
That's massive. What's the catch?
The catch is commitment. You need to make a 1 or 3 year commitment to a specific instance size or vCore configuration in a specific region.
Ah, okay. Lock in.
A commitment, yeah. But for predictable, always-on workloads, that commitment translates directly into massive savings. It's like buying your cloud resources in bulk, upfront.
So requires careful planning.
Incredibly powerful, but yes, requires careful planning. You need to understand your workload stability and have some idea of future growth before committing. You can apply reservations at different scopes, single subscription, resource group, or even shared across your whole Azure enrollment, so there's flexibility.
But if things change drastically.
Right. If your workload is highly volatile,
Yeah.
or you anticipate major architectural changes soon,
Mm-hmm.
a reservation might not be the best fit, or you might need shorter terms. The action here is action proposed. Analyze your historical usage data. Look for stability. If you see it, seriously consider purchasing 1 or 3 year reserved instances for your predictable Azure SQL Database deployments.
And don't forget dev test pricing.
Absolutely not. Azure provides lower rates specifically for non-production environments. You can set up Azure Dev Test subscriptions or designate resource groups for this.
And the benefit?
The benefit is huge. It lets you perform high-fidelity testing, meaning your test environments can closely mirror production and scale and config without paying those full, often much higher production prices.
Smart resource allocation.
Exactly. Ensures you don't inadvertently inflate your bill just for testing, staging, QA, or development activities. These don't directly generate revenue, so why pay premium prices?
Makes total sense. The action.
Action proposed. Straightforward. Ensure you are using dedicated dev test subscriptions or resource groups for all your non-production workloads. Development, testing, staging, QA, everything. There's usually no good reason to pay production prices for those. You can even implement Azure policies to enforce that new non-broad resources land in the right subscription type. Get that practice embedded.
Okay, so beyond those financial instruments, let's look at performance and sizing. This feels like where data engineering expertise really comes into play, right? Where technical optimization directly equals financial savings.
Absolutely. This is where you get granular with the resources themselves. First up, right sizing with monitoring.
Continuous vigilance, you call it.
Exactly. You need to constantly monitor key metrics, vCore utilization, memory consumption, IOPS, input-output operations per second. The goal is simple. Avoid over-provisioning.
Paying for what you don't use.
Right. If you're consistently paying for capacity that's sitting idle, that's just wasted money. It's like buying that supercar and only driving it in a 20 mile per hour zone, massive overhead, minimal utilization. You want to ensure you're only paying for what your database truly needs to perform optimally and no more.
So the action for the Cloud Database Pro here.
Action proposed. Collect and visualize these key performance metrics diligently. Use tools like Azure Monitor, Azure SQL Database Analytics, maybe third-party monitoring solutions. Set up dashboards, set up alerts. Review them regularly, maybe weekly, maybe monthly. Identify those opportunities to scale down.
What's a good rule of thumb?
Well, if your average vCore utilization is consistently below, say, 30 or 40%, you're very likely over-provisioned. Conversely, if you're constantly maxing out, you might need to scale up to maintain performance. But first, make sure you're not just throwing more resources at an inefficient workload, which leads to the next point.
Which is query and index optimization, the classic DBA task.
Classic, but with profoundly direct cost implications in the cloud. Improving your database performance through efficient queries and implementing an appropriate indexing strategy can dramatically reduce resource consumption.
How direct is the link?
Very direct. More efficient queries mean less CPU needed, less memory pressure, fewer I/O operations, all of which directly translates to a lower overall cost, especially in the vCore model where you pay for those resources. A single poorly performing query might consume 10 times the resources of an optimized one, hitting your bill hard.
Wow. Okay, so that's foundational. Practical advice for optimizing.
Action proposed. Reduce your resource usage by actively optimizing performance. Leverage built-in features like Azure SQL Database's Query Store. It automatically captures a history of queries, execution plans, runtime stats. Use it. Identify those problematic resource hogging queries or query regressions after changes.
And indexing.
And implement an appropriate indexing strategy. Don't just create indexes everywhere. Too many can slow down writes and take up storage. Too few obviously kill read performance. Regular index maintenance, statistics updates, query tuning. These aren't just about making things faster. They are fundamental cost-saving activities in the cloud.
And thirdly, underperformance. Dynamic scaling.
Using that cloud elasticity.
Exactly. Why pay for peak capacity 2 and 47 if your demand fluctuates? The ability to adjust resources up or down to match real-time application demand is a powerful cost-saving lever that, honestly, many organizations still underutilize.
How do you implement that? Action proposed. Follow the guidance on dynamic scaling available in the SQL database documentation. For example, the vCore model has that serverless tier we mentioned, which has built-in auto-scaling and can even scale down to zero compute during periods of inactivity. You only pay for compute when it's actually being used.
What about other tiers?
For other tiers, you can implement automation. Use Azure Automation runbooks, maybe logic apps or custom scripts. You can scale your database's vCores or even storage based on schedules like scale down every night and back up in the morning, or based on performance metric thresholds from Azure Monitor. Configure your databases to scale automatically or on a schedule to ensure you're always cost efficient. Pay only for what you need when you need it.
Okay, that makes a lot of sense. Finally, within these strategic levers, you mentioned a specific cost-saving DR strategy that often gets missed.
Yes, this one is quite clever and can lead to really substantial licensing savings, particularly if you're using SQL Server. It's the license-free standby replica.
License-free, how does that work?
If you have a secondary database instance that is used only for disaster recovery, meaning it has absolutely no active read workloads running against it, it's purely a passive standby waiting for a potential failover. You can designate it as a standby replica under specific licensing rules.
And the benefit?
The significant benefit is that you become eligible for substantial licensing cost savings. You don't have to pay for the SQL Server software license on that passive DR instance.
Wow, that's a game changer for DR costs, right? Especially with things like failover groups.
It really is. It means you can build robust DR solutions, like using failover groups for mission-critical apps without effectively doubling your SQL Server licensing costs just for the DR site. It lets you achieve business continuity without breaking the bank on infrastructure that's just sitting there passively most of the time.
So what's the action here? How do people take advantage of this?
Action proposed. Explore this option meticulously. If your secondary DR database is truly passive, strictly used for disaster recovery, no active read or write ops hitting it, then investigate configuring it as a license-free standby replica. You'll need to consult the latest Azure SQL Database documentation and maybe your Microsoft licensing agreement for the specific eligibility criteria and configuration steps. But it can be a major win for reducing your overall licensing spend within your DR strategy, freeing up budget for other things.
Fantastic tip. Okay, so we've talked architecture, we've talked strategic levers, but none of it really sticks, does it, without a robust framework? This brings us to our implementation highlight, establishing financial governance or, FinOps.
Right, and this isn't a one-time setup. It's an ongoing, continuous discipline. It requires cultural shifts, not just, implementing a new tool.
So what's the key to success here?
Establishing a mature FinOps practice is crucial. It's really about integrating financial accountability directly into your cloud operations and your engineering culture. It means moving beyond just getting that bill at the end of the month and kind of shrugging.
Yeah.
It's about actively understanding where your money is going, why it's being spent, and importantly, who is accountable for it. It's about empowering teams with cost data and creating that feedback loop for continuous optimization.
Okay, so what are the core components?
Well, one core component is the regular reconciliation of your Azure invoice with the detailed usage data. This means actually downloading those raw usage files, understanding what each line item represents, which can be cryptic sometimes, and connecting it back to specific services and resources.
Getting into the weeds of the bills.
Yeah, exactly. It's a deep dive into your own spending data, looking for anomalies, unexpected cost spikes, maybe identifying underutilized resources that just keep costing money. That raw data is your ground truth for cost analysis.
And perhaps even more importantly,
it's about implementing a consistent resource tagging strategy. This is absolutely critical and honestly often underestimated or done poorly.
why is tagging so important?
Because by consistently tagging every single resource with meaningful metadata, things like owner, cost center, project, environment, like production, dev, test, application name, you transform that raw, uncontextualized billing data into actionable reports.
So you can slice and dice the costs.
Precisely. It allows you to accurately attribute costs back to the correct team, project, or environment, which then enables you to detect waste, identify spending trends, and most importantly, ensure accountability. Without tagging, your bill is just a big, opaque lump sum. With good tagging, it becomes an organizational chart of your cloud spend.
Okay, this sounds like a critical action item, not just for database pros, but for any cloud team.
Action proposed. Absolutely. Implement robust financial governance practices. This includes not just using tools like Azure Cost Management plus Billing to plan, track, and forecast costs, but making resource tagging a mandatory, consistent practice across all your deployments.
How do you enforce that?
Use Azure Policy to enforce tagging standards. Define your required tags and make sure resources can't even be created without them, or flag non-compliant resources. It's the only way to truly understand allocate and optimize your cloud spend effectively, and drive that culture of cost consciousness.
Okay, really important stuff. Now, to give folks a broader perspective, especially when they're doing initial architectural planning, let's do a high-level comparative analysis. Let's look at Azure SQL Database against, say, the other two big players. Amazon RDS for SQL Server and Google Cloud SQL for SQL Server.
Good idea. And this isn't about declaring a winner, right? It's about understanding the core philosophies, the different approaches, and the strategic implications that differentiate each, helping you navigate that build versus buy or which cloud decision for your SQL Server workloads. And yeah, keep in mind this is based on public docs as of roughly mid-2025. Things change fast.
Always. Okay, so starting with Azure SQL Database differentiators, remind us of the core model.
Its core model is that fully managed platform as a service, PaaS. It abstracts away a lot of the deep OS and engine control, letting you focus more on the application, less on the infrastructure.
Purchasing models.
As we've covered, you've got the vCore model for granular independent scaling and the DTU model for simplicity and bundled resources. A key strength is its native serverless tier within vCore supports auto-scaling, scales to zero compute. Huge cost flexibility for intermittent workloads.
High availability.
Provides zone redundancy for that 99.9995% NLA, and importantly, that's included by default in the business-critical tier. Enterprise-grade resilience out of the box.
And the big cost levers.
The powerful Azure hybrid benefit and that license-free standby replica we just discussed. Often very significant for organizations with existing Microsoft investments.
Unique differentiators for Azure SQL.
I'd say failover groups stand out for really simplifying DR by providing that stable listener endpoint, abstracting away connection string changes during failover. And also its comprehensive built-in threat detection, like Microsoft Defender for Cloud, offering integrated security.
So the narrative for Azure SQL Database is?
Premier choice, maybe, for enterprises where that granular cost management, deep Microsoft ecosystem integration, and those out-of-the-box enterprise features are paramount. Offers potentially maximum financial and technical control, especially if you can leverage existing Microsoft licenses effectively.
Okay. Moving on to Amazon RDS for SQL Server differentiators. How does its core model differ?
Its core model is also managed service, but it's built more visibly on EC2 instances. This gives you a little bit more control over the underlying instance configuration, which appeals to teams who maybe prefer a more IS-like managed experience.
Purchasing model.
It's instance-based. You pay for the EC2 instance size, the vCPUs, the RAM, and the storage type you choose, much like provisioning a virtual machine.
Serverless.
Notably, RDF doesn't have a native serverless offering specifically for SQL Server. You'd need to manage scaling more actively yourself, or maybe integrate with other AWS services for bursting or pausing.
High availability on RDS.
The Amazon RDS uses multi-AZ deployments. This involves synchronous replication to a standby instance in a different availability zone within the same region. Provides robust in-region resilience.
Cost-saving levers.
They offer license mobility, allowing you to bring your own SQL Server licenses, similar to AHB. And they also have reserved instances for commitment-based discounts, similar to Azure's reservations.
Any unique differentiators for RDS SQL Server?
A really strong one is Performance Insights. It's a purpose-built dashboard, very powerful, that helps you diagnose and solve performance challenges within your SQL Server instance. It gives deep visibility into waits, queries, bottlenecks. Very useful for troubleshooting.
So the narrative analysis for Amazon RDS for SQL Server.
It's a mature, very robust platform, built on that philosophy of managed instances with good underlying control. It appeals strongly to teams comfortable with an infrastructure as a service-like paradigm, and obviously those already deeply invested in the broader AWS ecosystem. Performance Insights is a definite plus for complex performance tuning.
Okay, finally, let's look at Google Cloud SQL for SQL Server differentiators. Core model.
Also a managed service, similar foundationally, running on compute engine VMs, Google's virtual machines.
Purchasing. Serverless.
Like AWS RDS, its purchasing model is instance-based. You pay for the machine type, CPU RAM, and the storage. And also, similar to RDS, no native serverless offering specifically for Cloud SQL for SQL Server. Requires traditional scaling management.
High availability on Google Cloud.
Google Cloud SQL offers an HA configuration. This creates a standby instance in a different zone within the region, conceptually similar to multi-AZ, providing that zonal resilience.
The cost-saving levers there.
Their primary lever is committed use discounts, or CUDs. Offer savings for consistent usage over 1 or 3 years, similar to reservations reserved instances. However, Google Cloud doesn't have direct license mobility for SQL Server in quite the same way Azure or AWS do, with 8HB license mobility. That's a key difference.
Okay, what about unique differentiators for Google Cloud SQL?
I think the truly unique differentiator is its seamless BigQuery federation.
What does that let you do?
It allows for direct data analytics. You can run complex SQL queries in BigQuery, Google's data warehouse, directly against your operational SQL Server data in Cloud SQL in near real time without needing complex ETL extract transform load processes.
Wow, query across them directly.
Yeah, that's a significant advantage for organizations heavily invested in GCP's data analytics stack. Enables direct analytical insights from live operational data without the usual data movement headaches.
Very interesting. So the narrative analysis for Google Cloud SQL for SQL Server.
Its design focus seems to be on operational simplicity and that deep integration with Google's very powerful data analytics and machine learning ecosystem. That BigQuery federation capability is really a standout feature if you need real-time analytics on operational data without building complex pipelines.
So wrapping up the comparison.
Yeah, each cloud provider, Azure, AWS, Google Cloud, offers a compelling set of features for running SQL Server. They just have different strengths, different cost implications, different integration points depending on your specific needs, your existing investments, and your preferred ecosystem. It's definitely never a one-size-fits-all answer. Understanding these nuances, though, can really help inform your multi-cloud or single cloud strategy.
Okay, fantastic overview. To bring it all together then, mastering the cost of Azure SQL Database, it really is a continuous discipline, isn't it?
Absolutely. It truly sits at that intersection of architecture, operations, and finance. It's not just one team's job. It has to be a collaborative effort requiring ongoing attention.
It really begins with making those deliberate, business-driven architectural choices right from the start.
That means carefully considering vCore versus DTU, selecting the appropriate service tier that truly matches the workload's needs, understanding the nuances and costs of zone redundancy, and strategizing your disaster recovery based on those concrete RTO and RPO requirements we talked about.
Every one of those foundational decisions has direct, often significant cost implications that just rickle through your entire cloud spend.
Totally. And then once those foundational choices are made, you strategically apply those financial instruments, leveraging Azure Hybrid Benefit if you can, exploring reserved instances for predictable workloads, definitely using dev test pricing for non-trod, and maybe even exploring that license-free standby replica for passive DR solutions.
These levers can fundamentally change the cost equation, deliver substantial, sometimes immediate savings.
They really can.
Yeah.
But ultimately, true and lasting cost optimization. That's only achieved when financial governance becomes a core part of the engineering culture itself.
The essence of FinOps.
That's the essence of FinOps. It's about integrating financial accountability into every aspect of your cloud operations, from design to deployment to daily management, fostering a culture where every engineer feels like and acts like a steward of cloud spend. That's the key to building solutions on Azure that are not only powerful and highly available, but also profitable and sustainable in the long run.
So as you, our listener, reflect on today's deep dive, we want to leave you with a thought-provoking question. What actions are you taking right now to optimize your cloud costs?
Yeah, think about those architectural choices, those financial levers we discussed, and especially how are you integrating financial governance, that FinOps mindset, into your engineering culture?
Are you truly empowering your teams with cost, data, and accountability? Or are you still just reacting to the monthly bill after it arrives?
We hope this deep dive has provided you with a clear roadmap, some actionable steps to take control of your Azure SQL Database costs. Remember to like, subscribe, and follow for more weekly deep dives into databases, data engineering, and architecture.
Until next time, keep optimizing.
Don't miss out. Smash that like button, subscribe, and explore our other videos in the playlists.